Here are some important terms you need to know about angles in trigonometry. First of all, an angle in standard position is an angle that has its initial side on the positive x-axis at 0 degrees or 0 radians, and its terminal side somewhere else. In this case, I put its terminal side in quadrant 2. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. I drew what I attempted to be as a 120-degree angle, or hopefully you remember that that would be 2 pi over 3. So that's an example of an angle in standard position. I can measure an angle in standard position as a positive angle if I go counterclockwise, or as a negative angle if I go clockwise. So in a negative sense, this would be a negative 240-degree angle, or negative 4 pi over 3. So those are both considered angles in standard position as long as it starts at 0 and then we rotate either positive or negative direction. That's an angle in standard position. Now, coterminal angles are angles with the same terminal sides. I've actually done a coterminal, these are coterminal angles. You can find a coterminal angle by adding or subtracting multiples of 360 or 2 pi to an angle. So if I take 120 and I subtract 360, I get negative 240. Or if I take 2 pi over 3 and I subtract 2 pi, I would get negative 4 pi over 3. Let's look at an example where we add. So here we have an angle of 30, or pi over 6. If I add 360 to that, basically I'm taking an angle and I'm going all the way around and then some, and I get an angle of 390 degrees, or pi over 6 plus 2 pi, which would actually be 13 pi over 6. You're adding 12 pi over 6, which is 2 pi, to 1 pi over 6, which would be 13 pi over 6. So I'll write that down for those of you who may be somewhat fraction challenged. Okay, so those are examples of coterminal angles. Now there are an infinite number of coterminal angles because I could add 30 plus 360 plus another 360. And so it would be 390 plus 360, and that would be another coterminal angle. Or I could subtract 360 or subtract 2 pi multiple times. So those are known as coterminal angles. Now, a reference angle is an acute angle between the x-axis and the terminal side of an angle. So let me just use my example of 120 degrees. When we're dealing with trigonometry, we're dealing with right triangles, but I can't make a right triangle with 120 degrees. So what I do is I create a related angle, which is called the reference angle, and that angle is between the x-axis and the terminal side of my angle. So this angle would be 60 degrees. That is the reference angle. So theta reference is equal to 60 degrees. Now, I can have reference angles in other quadrants too, so let me just quickly show you reference angles. In quadrant 1, my reference angle would just be the same angle as the triangle, or as the original angle. In quadrant 3, my reference angle would be here. In quadrant 4, so here's the original angle, in other words, would be a quadrant 3 angle, and that's the reference angle. Here I have an angle that goes all the way around to quadrant 3, and the reference angle would be this acute angle. So the reference angle is always positive, it's always acute, and it's always measured to the x-axis or from the x-axis. So you never have a reference angle that is connected to the y-axis, always the x-axis. The unit circle is a circle with radius 1, and that means when I draw an angle, a reference angle, I can create a triangle here, and I know that the hypotenuse of this right triangle is 1, and that's going to come in handy when we label our unit circle to figure out some sine and cosine values. So make a note of these things, make sure you understand them.